Okay, let's continue Unit 1, Lesson 1. We are now on to inverses. Okay, the inverse of a function. First of all, let's look at our points. Okay, this becomes real easy. If I want to know a point inverse, okay, I literally take my x and my y and I swap them. It becomes 2, 4. You do not have to swap them and negate them. No, just flip them. The x becomes y and the y becomes x. All right, so here we got 7, -2, -3, 0, and -1, -6. These are the point inverses. So how do you find the inverse? You literally switch your x and your y. That's it. All right? Now, we've talked about function notation, f of x. All right? That's not multiplication. That's simply notation for a function. If I want the inverse of a function, I also have notation for that. And it's this thing right here. The only difference is you put this little -1 right in front of the f. Okay? That is not an exponent. It's in the exponent position, but it's just notation. There's no math to be done there with notation. It's just telling you this is not the function f of x. This is the inverse of the function f of x. Okay? And before we move on any further, I'd like to explain to you what a one-to-one function is. And before I do that, I'd like to have you recall, well, what's a function? A function is where every x has at most one y. Meaning, I can have 3, 6, and I can have 3, no, that I cannot have another 3. I can have 3, 6, and I can have 4, 6. Okay? That's a function because my x's do not repeat. In fact, if I were to draw that mapping, here my x's, here my y's, you have 3 and you have 4, you have 6 here. They both go to 6, and that's fine. That is a function because my x that's a 3 has only one y, 6. My x that's a 4 only has one y, that's a 6. As long as my x's do not repeat, that's a function. Now, what about this one-to-one function? Okay, my one-to-one function is, it's a function where every input x has exactly one output y. So a lot of students might get confused here. They'll say, well, isn't that a function? First of all, if something's a one-to-one function, yes, it has to be a function. But let me explain to you the difference. If it's 1 to 1, then the x and the y both cannot repeat. All right? This is a function. It is not 1 to 1. How come? Because my y repeats. All right? So that's the big thing. If a function is 1 to 1, the x's and the y's do not repeat. What if you have a graph? All right? What if we have a graph here? Well, let's draw a little graph. And let's put our favorite little parabola. Okay? The parabola. Well, we know about the vertical line test. I can tell that this is a function because a vertical line test will only touch this once, right? So, it is a function because it passes our vertical line test. But what about if it's 1 to 1? Yes. Not only does it have to pass the vertical line test, it would have to pass a horizontal line test. Okay, so 1 to 1, it must pass vertical line test and horizontal line test. This is a function, our parabola, but it is not 1 to 1 because it touches at 2 points on the horizontal line test. So it is not one-to-one. Because yes, it passes the vertical line test, but no, it does not pass the horizontal line test. It would have to pass both if I were looking at a graph to be one-to-one. All right? Not too shabby. Now let's take a look at example number 1. Write the inverse of this relation here. Okay? Is the relation a function? If so, is this a one-to-one function? Okay? So let's start with the easy thing, the inverse. All I'm going to do is literally switch my x and y, right? So it's -2, 2, 0, 3, 2, 4. I have literally switched my x and my y. That's the inverse done. Good job. Now, they're asking, is the relation a function? If I look at my original relation right here, is that a function? All right, well, what do I know about lists? My x cannot repeat, right? I'm abbreviating and shorthanding. My x cannot repeat. I have an x that's 2, I have an x that's 3, and I have an x that's 4. Do my x's repeat? No. So guess what? It is a function. Okay? It is a function. My x's do not repeat. If I were to plot those points, it would pass the vertical line test. All right? Well, now let's go into this third part. Is this a one-to-one function? That means the x's and the y's can't repeat. Okay? I know my x's don't repeat. What are my y's? I have -2, 0, and +2. Nothing repeats for the y's. There are no y coordinates that repeat or are duplicates. So guess what? Yes, it's 1-to-1. All right? Not too bad if you know the rules. Let's go on to our second example here. This graph. We have this graph. It looks like it's 2 lines, and we're going to graph the inverse of this function. Okay? We're going to graph the inverse. There's a little trick to graphing the inverse that can make it easier, but a lot of my students would rather just take the coordinate and flip it. For example, let's say this point is right here. That's the coordinates 3, 5. Okay. If I wanted to graph the inverse, I need to go to 5, 3. That's the inverse. Remember, I just flipped my x and my y. All right? Let's take a look at this point right here. That's at -2, 2. So if I'm going to graph the inverse, I go to 2, -2. Again, I flip my x and y coordinate. And last but not least, if I go right here, that's at -4, -4. You know the beautiful part about that? If I flip those coordinates, it's still -4, -4. So it'll be the same point. So what I do is I connect those. And that's the inverse. All right? Well, some people like what I'm about to tell you, and some people don't. If I have a graph, and I have the inverse, okay, by definition of a graph, okay, f -1, that's the inverse, is the reflection of my original function over the line y equals x. What do I mean? Y equals x is this line right here I'm about to graph in blue. Okay, here. Okay, that is the line y equals x. Do you see how my inverse, which I have graphed here in the red, is literally the reflection? Okay, it's literally the reflection of my original black line. See the points here? I'll do this in yellow. See this point right here is reflected across this line to this point right here. This point right here is reflected to this point right here. It's a reflection. It literally is a reflection. Okay. Some people are like, that's a lot to know. I'd rather just stick with flipping the coordinates, and that's fine. But every once in a while, this would help you. And again, it helped if I said y equals x, not y equals 1. All right, so now let's put this all together, okay? Now keep in mind, I'm just going over this. You need to pause or rewind things and hear me say something again. Or if you want to try some things on your own first, pause it, then watch me do it. That's fine. This is your time. Do what you want, okay? So what we're going to do here is we're going to find out the domain and the range of a function they give us. We're going to graph the function, okay? Then we're going to graph the inverse. They want to know, is the inverse we graph a function? And then we're going to find the domain and range of the inverse as well. All right? Notice they're not asking us to come up with the equation of the function, but we will just for hoops and giggles because we need to practice that anyway. Okay? So first, let's graph this right here. You can look on a graphing calculator. You can plot that. You can put that in Y1 and graph it, and then look at your table, and it gives you points to graph. Myself, I know that this is in slope-intercept form. This is my y-intercept, meaning that's where it's going to touch the y-axis at -4, right here. And I know my slope is 2, or 2 over 1. That means it goes up 2 over 1. So go up 2 over 1, up 2 over 1. I'm just going to keep on plotting these points until I run out of space, and I can go backward down this way. And that, my friends, is P of x. All right? Now, if I look at my domain and range, notice the arrowheads. Okay? This line goes on forever. So domain, let's not forget, those are my x values. This is going to go to the right forever and to the left forever. Okay? So it's going to go from -infinity to positive infinity. How do I know it's going on forever? The arrowheads are there. This will constantly go up and to the right forever. This will go down and to the left forever. It will never stop. So it will cover all real numbers. What about the range? Well, it goes up forever and it goes down forever, just like it goes left and right forever. So that is also from -infinity to positive infinity. Those are my y values. All right, let's look at the inverse. Now, in order to calculate the inverse, I switch my x and y. Okay? I switch the x and y. So, let me bring this up for a second. And you know what? For the sake of ease, just to not count, we'll wait to calculate, to actually algebraically figure out an inverse till the next page. Okay? So let's just figure this one out the easy way with the coordinates. All right? So let's pick some coordinates. If I know this is 0, -4, right there, I need to go to -4, 0 for the inverse. That's right here. That's at -4, 0. Now let's pick another point. Let's go here. We have 1, 2, 3, 4, 1, 2, right here. Okay, that's at 4, 4. The beautiful part about that is if I switch those, I'm still at 4, 4. I've got this line right here. All right, now you can just connect that 2 dots to the straight edge. You have your line. So let's pick another one just for hoops and giggles. This right here is at 2, 0. So the inverse of that would have to be here at 0, 2. Okay, so you see what I'm doing? And all I got to do is That is my inverse, p negative 1 of x. Again, I just pick some points, flip the x and y, and plot it. All right? Well, let's look at our domain and range for our inverse. Well, for my x's, it looks like it goes left and right forever. Negative infinity to positive infinity. My y values, that's the ups and downs on my graph. It goes up forever, and it goes down forever. So that is also negative infinity to positive infinity. All right, so if I look at my domain and ranges of the original function versus my inverse, maybe they'll always be the same. If you want to know how we check that, let's do another one and see how that works. Okay, so I'm going to go right here. And let's plot q of x. All right? Q of x is a parabola. All right, that's a parabola. You can put that in y1 and check out the points in your calculator on your table. Or, I know this is just a regular parabola, so it's going to drop down 3 spots. Okay, so I'm going to go to negative 3. And then I'm going to put a point here and a point here. Okay, and at 2, it's going to be 1, 1. At 3, it's going to go up to 6. Okay, this is what my parabola looks like. All right? Now, you might have thought to yourself, how did you do that? I just know these tricks. You put it into y1 and solve it. Or if you want, ultimately what I do here is I put in points and I solve. I create my own little table. When x is 0, 0 minus 3 is negative 3. When x is 1, well, 1 minus 3 is negative 2. When x is 2, and so forth. I'm doing this math in my head to come up with coordinates. Okay, but you can look at your table of values if you need to. All right, that's perfectly fine. You have a calculator, use it. Domain and range. All right? My domain are the x values. That's the left and the right. This goes up and to the right forever. This goes up and to the left forever. Yes, it's going up, but it's also opening and getting wider and wider. So this goes all the way to the right forever and all the way to the left. So that will go from negative infinity to the left to positive infinity on the right. Okay? Range. That's my y variable. That's the up and the down. I'm going to tell you right now, yeah, it looks like it goes up forever. It looks like it goes to positive infinity. And it does. But what about the low end? How far down is it? It only goes as low as the vertex. Remember, a parabola has a vertex. A vertex is either the lowest point, if your parabola opens up like ours does, or sometimes a parabola opens down, right? So the vertex will be the high point if the parabola opens downward. For us, it's a low point. So a vertex is either going to be a high or low point. For our problem right here, that's a low point. That happens at negative 3. Okay, so that goes as low as negative 3. All right? Now, here, I don't know, this is a review for you guys. I'm going to put a square bracket here instead of a parenthesis. The square bracket means I'm including negative 3. There's actually a point right at negative 3, so I want to include negative 3, so I do a square bracket. Anytime I include the number, it's a square bracket, not a parenthesis. All right? Not bad. Let's do the inverse of this function, and let's pick some points. Okay, I'm going to pick this point right here, the actual vertex. That was at 0, negative 3. All right? 0, negative 3. So that's going to be at negative 3, 0. That makes sense. All right, well, let's pick some other points. Let's pick these next two. This here is at 1, negative 2. So I'm going to put it at negative 2, 1 right there. this big point right here, that's at -1, -2, which means I flip those around, I'm going to -2, -1 right there. And I think that's, I can kind of just tell you it's kind of go like that. All right. Now, we're going to do something we didn't do with the other one. We didn't answer, is it a function? Okay, let's go back. Is this one a function? Does this green line pass the vertical line test? Yeah, it is. No matter where I put a vertical line, that only touches once on my inverse, the green line, the green graph. So guess what? Yes, our inverse here is a function. Let's go back here. If I draw a vertical line for my inverse, that touches my red graph, my red parabola, twice. So guess what? No, that's not a function. Let's take a look. Let's take a look, and we're going to do this here. Just give it a back. Get that graph back in there. We said, no, that's not a function. The domain. That's my x value. That's my left and right. It goes right forever, doesn't it? So it's going to go to positive infinity. But how far left does it go? It only goes to here, to -3. Oh boy. That's a number. It includes -3. So I want to do the square bracket. What about my range? My y goes up and down. This goes to the right forever, but it slowly goes up forever. This goes to the left forever, but it slowly goes down forever. Negative infinity to positive infinity, because it goes up forever and down forever. This will constantly get wider and wider, my red parabola. So it will go up and down forever. Hey, that's interesting. Look at my domain for my original function. That's my range for the inverse. Look at my range for the original function. That becomes the domain, my inverse. But the first one, they were the same, weren't they? Yes, that's because domain and range were the same. Technically, my domain did become my range. Okay, and my range did become my domain. It didn't look like that because my domain and range were the same. Okay, if you're confused now, let's say this was the number 3 and this was the number 3. If I flip them, it's still 3 and 3. They look the same. But as we did our second one here, we noticed they flip. So ultimately, when we compare the domain and range of the function its inverse, what do we notice? The domain of the original function, f of x, is the range of the inverse. Okay? And the range of the original function, f of x, is the domain of the inverse. I mean, think about it. Don't our x's and y's flip when we go from the original function to the inverse? Well, this is the x domain. It becomes the y of the inverse. And the range is the y. We're going to flip that and make it the x of the inverse. So it just all holds true. Okay? Not too bad. One more page, I believe. All right. This is where we are going to find the inverse of a function. And we need to come up with the equation, not just the graph. Okay? The last two graphs we did, it was nice, it was easy. We had coordinates, we just flipped them. Okay? And all we had to do was come up with a picture. We drew the line, we drew that parabola, but we didn't have to come up with the equation for them. Here, for examples 3, 4, 5, well, there's no 6. The next 3 examples, we actually need to come up with the equation of the inverse if we only have the equation of the original function. And it's real easy. It falls right in line with everything we've been doing. All right? What do we know about a function and its inverse? All we do, even with the domain and range, we switch the x and the y. We're going to do the same thing here. Nothing's going to change there. Same method. Okay. Keep in mind, this is the same thing as saying y equals 3x minus 4. I'm literally going to switch my x and y. Just the letters or variables. I'm not going to take the 3 over with the x. I'm literally going to switch this. I got x equals 3y minus 4. Once I do that, now I just solve for y again. Okay? So, I'm going to add 4 to both sides. That x plus 4 equals 3y. Last step is the y alone. Divide by 3. Divide by 3. So this is my answer. But I'm not going to leave it y equals. They wanted the inverse, don't they? And how do we write the inverse? F negative 1 of x equals x plus 4 over 3. Now, you might say, well, mister, shouldn't I break that up? Shouldn't I say x over 3 plus 4 over 3? Sure, go ahead. It's the same thing. That's fine. All right? So if you want to do 4 and 5 on your own and see if you can do them, pause this because I'm about to do them now myself. All right? They added something a little different here. The square root symbol or function is now in here. I'm still going to do the same thing. This is still y equals the square root of x minus 2 plus 5. I'm still going to switch my x and y. So I have x equals the square root of y minus 2 plus 5. Little tip here, children. Anytime you need to get rid of a square root symbol or a square root function or operation, you need to get it alone first. Meaning, on the right side of my equation, I have the square root of y minus 2 plus 5. I want to get rid of that 5 first. I'm going to subtract 5 from both sides. I've got x minus 5 equals the square root of y minus 2. All right? Now, just like earlier here with some of this math, when we're solving, we do the opposite, right? The opposite of a minus 4 would be plus 4. The opposite of 3 times y would be to divide, because the opposite of multiplication is division. The opposite of addition is subtraction. The opposite of square root is to square something, which means this will cancel with this. And on my right side, I'll have y minus 2. What I do to one side, I have to do to the entire other side. That is not x squared minus 5 squared. That's not x squared minus 25. You actually have to take x minus 5 and multiply it times itself, x minus 5. All right? And if I do that, I'll get x squared minus 10x plus 25. Okay? So I have x squared minus 10x plus 25. What's the last thing I need to do to get my y alone? Is I need to add 2. So x squared minus 10x plus 27 equals, I'm not going to put y. They want the inverse of g. So g negative 1 of x. There you go. Quick point. If this were multiple choice and you did not see this, sometimes, instead of foiling this out, sometimes they might leave it like this. They might say that's x minus 5 squared. So instead of having this, they might have x minus 5 squared and leave it alone. And then if you add 2, you might see it like this. I doubt it. This is algebra 2. You should know how to FOIL. Okay? And this is what you should come up with. But you never know. They like to be sneaky sometimes. What I bubbled here in blue is the same thing value is that right there. Okay, all they, for this top one, they would have been lazy, and they would have left it like x minus 5 squared without FOIL. But I expect you to FOIL this in my class. FOILing is real easy. Okay? Number 5. Something different yet again, because we would like to see the many ways you might have to do this. All right? Let's extend this. We now have, let's see how we're doing. Okay, well, 30 minutes. Thank God it's the last one. We have y equals x plus 2 over x minus 5. I have 2 x's. Guess what I'm going to do? I'm still going to switch my x's and y's. So, on this side, instead of y, it's x equals. Instead of an x here, y plus 2. Instead of an x here, y minus 5. I switch my x's and y's. Now I just solve for y. But Visca, there are 2 y's. Yes, that's why we're going to use algebra to make it so there's 1 y. All right? The first thing we're going to do is put this over 1, and I'm going to cross multiply. 1 times y plus 2, well, that's just y plus 2. Okay? X times y minus 5. There you go. I cross multiply. I'm going to want to distribute, let me rid of these parentheses. Okay? I'm going to distribute my x. That y plus 2 equals xy minus 5. At this point, I don't think we've done anything crazy. We've cross multiplied and we've distributed. Nothing crazy. Here's the whole key to solving this problem. If we are trying to solve for y again, we want to get everything that has a y on one side of the equation, of the equal sign. And everything that does not have a y should be on the opposite side. Okay? So, let's take a look at what we got. Well, I know, okay, I want to get this on the same side as this. So I'm going to subtract x, y from both sides. Boom. Which means I want to get rid of my 2 on the left side. I'm going to subtract 2. Subtract 2. So what do I have? I have y minus xy equals negative 7. All right. Nothing too crazy. Now, here's the whole reason we wanted to get everything with a y on one side. I'm now going to factor out a y. They have a common term. They have a y, right? 1 minus x left. That's it. I factor out a y. When I factor out something, is it like dividing? Right? This turns into 1. This goes away. It just turns into my minus x. All right? Now look what I have. I have 1 y that I can solve for. How do I get it alone? Well, how about I just divide this side by 1 minus x and divide this side by 1 minus x? There you go. And what is this? J of x? What the heck is this thing? J of x. So j, negative 1 of x equals negative 7 over 1 minus x. Now, if you did this on your own, and I did this here, and you came up with something different, all right? Some people, at this point right here, instead of adding 2, or excuse me, instead of subtracting 2 from both sides, maybe they switch things. Meaning, if I had this right here, some people would have said, well, how come I'm going to add 5 to this side, and then subtract y from this side? So we've gotten 7 equals xy minus y. All right? If I factor out a y, that's what you would have gotten. Divide by x minus 1, you would have ended up with this right here. That is technically the same thing as this right here. How so? Because if I factor out my negative from my negative 7, okay, and apply it, if I multiply it both the top and bottom by -1, you'll get the same thing. These are the same thing, okay? These are the same thing. So don't freak out. You would have gotten credit if you would have done it that way as well. All right? And that is the first unit, first lesson completely done.